Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to be talking about the halogenation of alkenes, specifically the addition of halide compounds, generally shown as X2, across pi bonds. Now, in this reaction, we have diatomic halides that are acting as electrophiles, while pi bonds are acting as nucleophiles in this reaction. In general, we have the creation of a halonium ion. The example we'll go through today in this video is bromonium. And this also gives the anti-addition of halides to that alkene. So let's talk about the mechanism. Okay, so this is a typical reaction of an alkene reacting with bromine to afford this product, which has the two bromine groups anti to one another, which means that the dihedral angle between these bromines, shown here in green, is 180 degrees. And here's a Newman projection of that molecule looking down this bond, shown here with the arrow. Okay, so here's the mechanism. So we have first the alkene, again, acting as the nucleophile. And we know that bromine has 6 non-bonding electrons. So we use 2 of those electrons to attack this unsubstituted terminus of the alkene, while the substituted terminus of the alkene attacks that same bromine, and then the bromine-bromine bond breaks. And this happens all in one concerted step. So this leads to the creation of a bromonium ion, which is kind of a strange looking structure if you're not used to looking at it. The 3-membered bromine-containing bond is relatively strained, not relative to cyclopropane, but still a pretty strained compound, as well as there being a positive charge on bromine, which we know is in the second step, the bromine ion that is released from that last arrow of the mechanism I just drew, then is the nucleophile, an even better nucleophile than it was before, and attacks this carbon and breaks this carbon-bromine bonds. This leads to the product that I showed above. Okay, and one thing that's really important to notice is that anti-product that's formed. Those bromines are 180 degrees from each other. The dihedral angle connecting these bromines is 180 degrees. And this is always what happens in this reaction and results from this SN2 style attack of the bromine to that electrophilic carbon shown here in red. And this reaction is generalized to halides, except for molecular fluorine. So this will work with chlorine, bromine, and iodine as well. Okay, so here's some questions you might ask in office hour. 1, does the identity of the halide change the rate? 2, does the identity of the halide change the equilibrium position, that is the equilibrium constant? And 3, how do chemists know that the mechanism is correct? How do we know that this concerted initial step followed by an SN2 style nucleophilic attack is the right mechanism? So thanks very much for tuning in. See you next time.